So you see, we actually needed to create two functions to demonstrate some concepts here. But we're not done yet. Let's go ahead and make it do exactly the same thing as this one to save some time. Just basically Control-C and Control-V. It doesn't need to do anything different. It just needs to create a printout, but it will create a printout of doubles. Nothing more, nothing less. And we can even add it. We can even add it here. Like, oh wait, I don't need that. I can just do it here. No big deal. Double. And we can do it here like int, so that we can differentiate the printout. I mean, obviously we'll see the different numbers, but maybe it won't, or maybe not the different numbers, depending on the arrays that we create. Okay, so this is going to work. You see, hopefully, if I didn't make any mistakes. Excellent. So you see, this is an array of integers. Okay, no problems. Let's go back into the main function and just create another array. It's going to be of doubles. Doesn't need to be the same size. It can be pretty much any size. Okay, so let's just have three numbers. So 4.34, 3.1, and we can place like -2. Double. Okay, so this will be ARR1. This shall be 0, 0, and this shall be 0, 1. We can name them so. I mean, the naming is arbitrary, of course. And what we want to do here is type in 0, 1, because we are going to pass a double. So you see, we're not changing the function call, we're just changing the parameter that is being passed. And we can go ahead and run this. What is the, right. Okay, sorry. So 0, 1. 0, 1. Didn't change the names here, my apologies. And oh man. One humiliation after another, I guess. Can look at it that way. Let's go ahead and run it. Okay, see? Now it says double. -2, 3.1, 4.34. Oh, but take a look at this. The size of a double is not the same as the size of an int. The size of double is 8 bytes, and the size of an int is 4. So it takes more memory space. It reserves a greater amount of memory space. You can check out the sizes in terms of bytes for all the types in C++. You can do that on the net. I really don't feel like listing them out here, and there really is no need for me to do that. And we can, you know what we can do? We can basically call this function twice, and twice we can, like, I don't know, we can place 0, 0, and now we can place 0, 1. So we can go ahead and run it again. And each time, as you can see, the program knows exactly which function to call. It knows whether to call the one where the argument, it knows whether to call the first one or the second one. It knows whether to call it knows this because the arguments passed to it are different. So if you pass an integer here, an integer array, it's going to, of course, create a printout of integers, and it's going to call the first function. If you pass in a double value, it will, of course, call the second function and will create a printout of doubles. So the compiler is intelligent in that fashion. It is able to recognize this without you actually having to change the names of functions. So this does help you a great deal, believe me. This is all good, fine, and dandy. No big deal, right? Fairly simple concept, but hey, what if we need a Boolean array or a char array? Then we would have to write a function for each of those. So imagine if you, for example, had 10, maybe 5 to 10 different types of arrays, and you needed to create this sort of a function overloading for each one of those types. For each one of those types, I can tell you it's a lot of code, like a lot. Especially if it's a little bit longer and you need to change all the names within the function, etc. It can be a painstaking process. So, in order to avoid this, we can use generic functions. They accept the type and print it out. The function body is the same for all types. So generic function is a function that is declared with type parameters, and when called, instead of those type parameters, actual types are used. The syntax is something fairly new. So let's take a look at the pseudocode for a generic function. So let me show you how you can create it, basically. Keep in mind that this is pseudocode. So template and type name, type. So instead of type name, you can also use like class, but this is definitely not recommended way of going about things. So just use type name. Anyway, down below, we shall go ahead and attempt to recreate our void print function. So void print, and instead of the parameters as we've been typing them thus far, like double array or int len, we're gonna go ahead and just type in type arr, do this, and then int len. Now this is, keep in mind that this generic function, this is a partial deduction because we already know that this is an array, but we do not actually know of what type it is, whether it's an integer, whether it's an array of integers or doubles or floating points or whatever. So we have no idea about that. Anyway, generic function, that would be a function that is declared with type parameters. And when called, instead of those type parameters, actual types are used. So keep that in mind. Here, as I stated, we will talk about partial deduction because we already know some information, like that it's array, just not a type. Okay, so let's go ahead and delete this. And since we have these functions that are overloading, we're going to go ahead and remove them as well, primarily due to the fact that we don't really need them anymore. And we can remove the two prototypes as well, as we do not need them. Again, you can leave them if you like, but I don't know, it doesn't really matter. Template, type name, type. So this will be a generic function with name type for generic type. I know it can be a little bit confusing, but bear with me here. So print type arr. Okay, so int len. Syntax is as has been shown, and we're not going to prototype it or anything. We just have one function, so we will write it out here. We're going to create basically the same body. Probably should have copied the body from the other functions, but just can't think of everything always. But if you have been amongst some of the people who have actually who have preserved the other functions, feel free to just copy paste the code. Otherwise, write with me. Okay, so len -1. Okay, plus I. A fairly short snippet of code. I, and now we're gonna need a comma with a space, and we need that if statement. Okay, so that's be 0, std cout 1 -1 and std cout. Okay, std, and oh, that was like super painful. Anyway, we have created the body of the function, And now we do not know what type of an array we are going to pass to this function. We can pass pretty much anything we want. That is the beauty of this. So let's go ahead and actually just rerun this code. There shouldn't be a need to actually change anything here, and we can just go ahead and run it. And there you go. Again, the printout is correct. It's working. And notice how we didn't need to create like 2-3 different functions. It's just one, and it's going to accept pretty much whatever you can throw at it, as long as this is an array, because we've basically made it so. It's generic. It can accept pretty much anything. So you see we have an int and we have a double, and we can also have like a float. Can have pretty much whatever you want. Feel free to play around with types and put random ones, whatever it is that you can put in. Feel free to put in. So try. If you get a list of all the types, or just use all the types that we have learned thus far and then try implementing them. In fact, we can even like do this. Let's go ahead with char. ARR, that's gonna be like, let's just use 03. Want to use char, but doesn't really matter. Okay, so I don't know, Q R or T and X and T again, whatever, it doesn't really matter, just some random order of letters. It is like completely irrelevant, it makes no difference. Okay, so let's go ahead and create another one. Print ARR03, then okay, so this is going to give the sizes from the different arrays. So that has to go, because even though the compiler won't actually report a mistake, you're going to get wrong length sizes here, wrong sizes of array. Why? Because this one is calculating the size for array 0, 1, and we have 0, 0, 0, 1, 0, 2, 0, 3. So we need to like remove that, and instead of len here, we will need to write individual lengths for each one of these. So it's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8. This one is like 2, 4. The one, what is this? Oh, this is actually 0, 0. Oh man, they're not in order. Well, forget about that. Let's put them like this: 0, 1, 0, 2. 03. Oh, actually, sorry, I'm 00. I know this day has been like 02, 01, 02, 00, 01, 02, and 03. Yep, there we go. So that's what I wanted. Anyway, for 00, it is 8. For 01, it is 4. And for 02, it's like 1, 2, 3. This is going to be 3. And this one's like 1, 2, 3, 4. So there you go. Let's go ahead and run the code now. It managed to print all of them out, and there seems to be a bit of a problem here. So let's go ahead and see what the problem is. So that would be like 0, 1. That's double. So 1, 2, 3. There you go. So we went outside of the boundaries of the array. I do believe that in Java you wouldn't be able to do this. It would prevent you, but in C++ you can. So it's -2, 3.1, -2, 3.1, 4.34, and then you have another extra element, which is just whatever occupied that RAM space at the time of compiling this. Okay, so let's go ahead and close this. I missed the array size. Apologies there. So let's go ahead and type 3 there, build and run. And there you go. Now it seems very much correct, and no problems there. Well, you can disregard these two. This is just something that's remained from the previous tutorial. But hey, there you go. So it's 1, 2, 3, 4 arrays that we have created here, and all 4 of them we've managed to pass to this generic function without actually stating without actually needing to know what it is that we need to pass to the function. All that we needed to know was that we're passing an array, and that array could have been anything. So the question now stands is, how does all this work? Well, it's not actually that complicated to understand. The compiler creates 4 functions that have the same body. Keep in mind, the compiler creates. So it literally creates a function that did not exist prior to you compiling the code. So you have these 4 functions shall be created. They all have the same body. That the compiler does that for us. Thank you, compiler.